So today we want to talk about roads, and the particular topic that we will discuss in this video session is 7 notable road failures around the world and their root causes. So roads are infrastructures that are very important in our economic pursuit as states, countries, continents, and even the world at large. So without roads, there is no commerce, there is no transport, and there is no movement of people. So whenever there is a road failure, or there is a road collapse or something of that sort, then this supply chain, roads facilitate the supply chain, so the supply chain is interfered with. So then as engineers, we need to analyze what are these critical things that causes these failures. We plan adequately for them so that we minimize these disruptions. So road infrastructure is critical for the functioning of modern societies, facilitating transport, trade, and communication. However, the integrity of road structures can be compromised by various factors, leading to catastrophic failures. Then this video will delve into 7 notable road failures from around the world, exploring their root causes and the lessons they offer to future engineering projects. So the first notable road failure that I want to discuss with you is in the US, California, and the road is called Big Sur. So this incident happened in 2017. There was a massive landslide that buried a significant portion of this highway. It's called Highway 1 along the Big Sur coast. This is one of the most scenic and traveled routes in the state of California. So after investigation, it was established that the primary cause of this failure was prolonged heavy rainfall, which led to soil saturation. The steep and rugged terrain of the Big Sur coast, combined with the geological instability of the area, exacerbated the situation. The combination of these natural factors resulted in the hillside giving way, covering the road with millions of cubic yards of earth and debris. So what are some of the lessons learned as a result of this failure of the Sur Road in California? So this incident highlights the importance of regular geotechnical assessment in areas prone to heavy rainfall and unstable terrain. Also, improved drainage system and early warning systems for landslide can mitigate such risk in future. So this just tells us we need to assess the soil condition around roads. We need to put in very good drainage systems, and as part of notifications, we need to have early warning systems that tells us the condition of the road, so that if there are maintenance, these maintenance are done at the appropriate time before such kind of accidents or failures occur. The second one, we go to China, on the border of China and Pakistan. The road is called Karakoram. So the incident is the Karakoram Highway, often referred to as the 8th wonder of the world. We shall maybe talk about why this Karakoram Highway is called the 8th wonder of the world. But if you already know why it is called like that, you can just share with me or with us on the comment section. So this Karakoram Road frequently experiences landslides and road blockages, disrupting travel and trade between China and Pakistan. So what is the root cause of these frequent road blockages and disruptions? This highway traverses one of the most geologically active regions on the planet, prone to earthquake, landslides, and extreme weather conditions. The region's complex geology, characterized by young and stable mountains, makes it highly susceptible to natural disasters. Part of lessons learned: engineering projects in geologically active areas must incorporate robust design features that can withstand seismic activities and landslides. Continuous monitoring and maintenance are crucial to ensure the highway remains passable. So this talks about seismic activities and also areas that are seismic active. So in these areas, the road design should be robust, and apart from being robust, the engineers should consider adequate factors of safety, and apart from that, routine monitoring should continue, and also installation of early warning systems will be very critical in terms of monitoring any possible damages, and even as part of a fast response plan should there be an incident. Then the third highway road failure, we go to India, the Morandi Bridge. So the Morandi Bridge connects the Indian mainland with the island of Ramswaram. So this partially collapsed in 1964 due to a powerful cyclone. What was the root cause of this failure? Yeah, it is that powerful cyclone that brought extreme wind speeds and heavy rainfall, which the bridge's structure could not withstand. The combination of the natural disaster's intensity and structural limitations of the bridge at the time led to its partial collapse. So what are some of the lessons learned due to the Morandi Bridge collapse? So infrastructure in cyclone-prone areas, I'll take that. Infrastructure in cyclone-prone areas must be designed to ensure extreme weather conditions. Modern engineering technique, such as aerodynamic design and the use of stronger materials, can enhance the resilience of such structures. So nowadays we've got very powerful design softwares that can model with a lot of accuracy the seismic cyclone events, and they give you design considerations that will make your structure, if it's a bridge, structurally sound, the way you should brace it, the way you should build your bridges foundations, and how rigid it should be. So if these are all considered, then you will make your bridge rigid, and also it gives you a time for failure. Then the number 4 structure road failure is the Tacloban Palo Road, and this is in the Philippines. This happened in 2013, and it was as a result of Typhoon Haiyan, one of the most powerful tropical cyclones ever recorded. In 2013, Typhoon Haiyan, one of the most powerful tropical cyclones ever recorded, caused severe damage to the Tacloban Palo Road, among other infrastructures. The root cause: the unprecedented strength of the Typhoon Haiyan, characterized by extreme winds and storm surges, resulted in extensive flooding and structural damage. The region's lack of adequate flood defenses and the road's suboptimal design for such extreme weather events contributed to the devastation. Lessons learned: this disaster underscores the necessity for comprehensive disaster preparedness plans and infrastructure designed to withstand extreme weather events. Incorporating elevated road designs and robust flood defenses can mitigate the impact of such disasters. So, as part of the ultimate design in structural engineering, they should have considered the extreme load condition, and in this case is this typhoon. It's called Typhoon Haiyan. So part of the loading condition should have been that. Sometimes the structural engineer gives out a design, but due to budget constraints, the lesser they take a lesser loading design, so which cannot withstand the actual event when it's finally exposed to these weather activities. Okay, number 5, Vant Dam Disaster. This happened in Italy. The incident was, although primarily a dam failure, the Vant disaster in 1963 caused massive downstream flooding, affecting roads and towns. A landslide into the dam's reservoir caused a massive wave that overtopped the dam and destroyed the town of Langaron. So actually this has also happened recently in Kenya.
In recent weeks, Nairobi has been battered by heavy rains, which have left a trail of destruction and suffering. One of Nairobi's poorest neighbourhoods of Mathare, where thousands of people have been displaced from their homes. It's one of Nairobi's informal settlements.
During the recent floods, there was mass wasting, a failure of a certain water reservoir. Then water rained down and killed more than 200 persons. For those of us who understand this event, you can also share your comments. If you are affected, please also share your comments so that we understand how this failure affected you. So root cause of this Vant Dam disaster is geological instability and heavy rainfall triggered a massive landslide into the reservoir. Human miscalculations and failure to properly assess the geological conditions played a significant role in the disaster. So you can see geological and geotechnical analysis is very critical for civil and structural engineering, design and infrastructure. The 6th one is Morandi Bridge. Again, this is in Italy, in a place called Genoa. So in 2018, the Morandi Bridge in Genoa, Italy collapsed, resulting in the deaths of 43 persons. And the collapse was attributed to a combination of poor maintenance, corrosion of the cables, and inherent design flaws. Investigations revealed that the bridge's structural integrity had been compromised over time due to inadequate maintenance and the use of outdated materials. As part of the lessons learned, this tragedy highlights the critical importance of regular maintenance and inspection of infrastructure. Implementing modern design standards and using durable materials can enhance the longevity and safety of such structures. The seventh failure incident that we will look at today in this video is the I-35W Mississippi River Bridge in Minneapolis, United States of America. So this I-35W Mississippi River Bridge collapsed in 2007 during rush hour, killing 13 people and injuring 145 other persons. And what is the root cause of this failure? The failure was caused by design flaws in the gusset plates, which were undersized and became overstressed over time. Also, poor maintenance and inspection practices contributed to the collapse. What are the lessons learned? This incident emphasizes the need for rigorous design standards and regular inspections, identifying and addressing potential weaknesses in infrastructure components can prevent such catastrophic failures. Yeah? Catastrophic failures. And I just want to also say, so in conclusion, as we conclude, so these notable road failures from around the world underscore the diverse challenges faced in civil engineering, from natural disasters to design flaws and inadequate maintenance. Each incident provides valuable lessons for future infrastructure projects. By learning from these failures, engineers can develop more resilient and safe transportation networks, ensuring that roadways can withstand the test of time and elements. So I hope from this 7 road failure incidences, you've had an insight of how what are the typical causes for these catastrophic failures, and what needs to be done in terms of correcting these mistakes. Good. Also, in the comment section, if you're interested in to understand how roads are designed and constructed, please have a look at that short course. It's just about 30 minutes. You'll be able to teach yourself if you are an upcoming civil engineer or in other fields and you interface with road designers. It's a very simple course, but you will get a glimpse of what happens when civil engineers design road. So yeah, so thank you very much. This is all we had for you during this video session. I hope you enjoy it. Thank you.
Before you leave, our team will be very happy if you can give this video a thumbs up. Remember to subscribe and click the notification bell so that you can be notified every time we upload a new video. Thank you for watching, and see you in our next video.